Hey guys, in today's video, you're going to learn more than you ever probably wanted to know about the Kelsey-Hayes EBC310 four-wheel anti-lock brake system that's used in the late 90s GMC and K trucks. We're going to diagnose a problem with the top piece here, which is called the electronic brake control module, and then we're also going to diagnose a problem that's tied to this middle piece, which is called the brake pressure modulator valve. We're going to end up replacing this entire assembly, but you'll get a chance to see it all taken apart and how you can do some root cause analysis. So stay tuned. All right, let me show you what the code looks like and how it manifests itself. So right now the vehicle's off. You can come over here on the dash. You can see I'm going to start her up. After we get past the lamp test, we see that anti-lock brake light went out. Now all it's going to take to set this code, I'm going to put her in reverse, we just have to go a few feet and get over 5 miles an hour so that that test will run and it will fail, and then I'll show you what the diagnostic code is for that test. Of course, I'm looking behind me, so I'm not going to see it trigger, but I got a feeling it should trigger right about now. Let's go back and look. Right, so there it's triggered. So we're just in the driveway here. We're just going to put her in park, and we're going to drop down and pull our Tech2 up so you guys can see, and let's go take a look at what the code is. So we're going to build the vehicle. 98, light truck. Now, we're not looking for a P code. You know, a lot of times when you look for codes, you're looking for P codes, but these ABS codes are C codes. They're in the chassis section, and that's why a cheap code reader is not going to pull them for you. You have to have a higher end tool. So we're going to come in here. We got a K truck because it's a K2500. All right, and then we're going to go into the four-wheel anti-lock brake system, and we're going to look for codes. And there's our code. C0268 pump motor circuit shorted. So that's the code here. Now this type of test is a test that is only going to be, or a type of code rather, is only going to be active while the vehicle is in the ignition cycle. Right? So if I come over here and I get out of this, and then I come back over here, the vehicle, right? We still got the anti-lock brake light lit on the dash, you see here, right? So now I'm going to turn her off. Just going to put the ignition back in the run sequence. We're going to come back to our Tech2. We're going to pull up our DTCs. And it tells us there's no code. Because that code, an ABS code is typically only active for the ignition cycle. But if we take a look at history codes, we should see it there. And there it is. So just that's a thing that the light will go out when you turn it off, so that the next time you start it, it's out. But then as soon as you get over 5 miles an hour in either forward or reverse, this type of code will set again. So something else we want to look at while we're in here is we want to come into, let's see, special functions, system identification. So later on I'm going to explain a little bit about the ABS system. And we want to have some way to identify the one that we have so that when we get a replacement, we can be sure we're getting the right kind of replacement. This is about the only information we're going to get from this ABS system. So we're going to get a software level, the software's date of release to GM, and then the particular platform, D78. So we're going to take note of that. And that's about the only other thing we can do on this particular test. Now, there's a bunch of tests that are going to be used later on to test things after we get the replacement done, after we diagnose exactly what's going on here. We'll end up having to replace something in the ABS system, guaranteed, with this type of code, unless it ends up being just a ground problem. Now, it could end up being a ground problem, and we'll go through that whole thing as the video rolls out here. But I'm pretty sure, because I take care of the grounds in this truck, that we're going to end up replacing something. So let's go and see. All right, there's two problems we're looking at with this ABS system. So we talked about one, so we can see the lights lit. We talked about the C0268 code with the pump motor. The second problem is one that's been around before this happened, and I've just been putting it off, and that's with the BPMV itself. So I'm going to accelerate and then do a hard braking, and you're going to watch the wheel here. You get up to a certain speed, over 20 miles an hour, and you hit the brakes really hard, You see how she pulls to the left? So a lot of times you get a pull like that, you would suspect the brake lines in the front or maybe the calipers, but it also can be the brake pressure modulator valve. And so that's part of also what we're going to go talk about when we do this. All right, guys, after you pop up the hood right near the master cylinder, this whole assembly that you see here is where your ABS system is. This is what we'll be working on. This whole thing here, the thing I got my hand on, this pump, which is what our short is being reported on, this whole thing is called an electro-hydraulic braking unit, or an EHBU in GM jargon. It's got several pieces. This piece on top that says Kelsey-Hayes. Kelsey-Hayes is the OEM supplier to General Motors. This whole thing is a Kelsey-Hayes EBC310. This top piece is called the electronic brake control module. This is the computer. It is bolted on with 4 Torx screws, and they're torque to yield, by the way, even back on these old 90s vehicles. This piece with the pump is called a BPMV, or a brake pressure modulator valve assembly. And then on the front that we'll see in a little bit later, there's actually another piece that bolts onto the front of the BPMV, and that's just the proportioning valve. These units are not common to all trucks. There are different EBCMs depending on the type of brakes your vehicle has. There are different BPMVs, and there are different proportioning valves. So even though they all cosmetically look alike, they are not alike. And that's why we took some information from the scan tool to know what's inside this EBCM in terms of its software date and version. But let's get started with diagnosing the problem. But one more thing I want to show you before we diagnose the problem is just about familiarizing yourself with the layout. So this is a gasoline-powered engine that this is in, and when you have a gasoline engine, this EHBU is going to be right next to what's called a VCM, or a vehicle control module. Gasoline engines will have this mounted here. Let me show you a quick clip of another truck that doesn't, a diesel truck that doesn't have this, so you can see the difference. The other thing I'm going to point out too is this gasoline truck, even though it's a 3/4 ton, this is a 98 Cheyenne K2500 with a 5.7 liter vortec V8 and the 4L80E automatic. It has, if you see behind the master cylinder, it has a vacuum brake booster. This is one type. There's also a hydraulic brake booster, and this is all important because it determines which of these you have in terms of what type of brakes you have. And I'll put some more information up in a minute, but basically if you have a vacuum brake system, if you open up your glove box, you'll find in the RPO codes, the regular production option codes on the sticker in the glove box, and I'll show that in just a minute, that you have a JB type brake. That's a Jimmy Baker. And if you have a hydraulic one that I'll show here just in a minute, then you have a JD type brake, which is a Jimmy David. So let's go take a look at what a hydraulic system and a diesel looks like before we get started diagnosing this code. All right, guys, the codes I'm talking about are going to be in the glove box. And in this case of this vehicle, if we come in here and look, we can see right by my thumb there, if we zoom in, this is a JB7 brake system. Let me go show you the hydraulic. So this is a vacuum brake system for a 3/4 or 1 ton type truck. All right, guys, so you can see in this diesel engine truck, there is no VCM. That's because diesel engines have a PCM, or powertrain control module, located behind the glove box. But we can still see our EHBU here, and you can see it cosmetically looks just like the one on the gasoline engine, even though these, like I said, are going to vary. You can see over here that the booster is hydraulic, not vacuum. It's powered off the power steering pump instead of being powered off of the engine, because obviously there's no vacuum to supply from a diesel engine. Also, if we take a look over here, just because the VCM's out of the way, we can see a better view of the BPMV here, and then we can see the piece that's bolted into the front of this, which is called the proportioning valve, and that's where you can see, for example, the pressure switch that's plugged in down here. All right, so let's get on to diagnosing it now that we've got some familiarity with what it looks like and how it varies from truck to truck. All right, this truck is a diesel, and same place in the glove box. And if I can get down here and kind of position it with my finger, we go inside and look, and we zoom in here, we can see JD7, because this is the same type of braking system in terms of the weight rating, but it's hydraulically controlled in the booster rather than vacuum booster. All right, guys, in order to diagnose this C0268 diagnostic trouble code, we're going to start with this page of the service manual. All right, so we got the second edition 98 service manual. We are working on a 98, so this is as good as it got. And what we're looking at here is this is the electronic brake control module. If we think back to when we talked about the different pieces earlier, we're plugged in on the data link connector to get the code. And what's of interest here is we've got a connector C3 where we've got power coming in from this relay, and we've got ground going over to G101. And then the EBCM also has a signal ground that ends up going to G104. Now, if you're interested in what all these different grounds are for these old body style trucks, I'll link up in the upper corner, a little white circle with an eye in it. You can click on it and it'll show you one of the earlier videos I did about that. But our diagnosis is going to be checking this circuit. This C3 connector, if we just flip back here a second, it looks like this. It's just a 2-pin connector. Red is power, black is ground, and then their circuit numbers are 442 and 150, which we see over here, 442 and 150. So if we take a look at the unit itself, we can see here is connector C3 plugged in right here. So our wiring harness comes in and plugs into this lower connector of the EBCM. Our pump motor is part of the brake pressure modulator valve assembly, the BPMV. It has a 2-pin connector on the other side, and one of the other tests we're going to do is to check that. So just real quick, I'm just going to show you the quick tests we're going to do. The first test that we're going to do, obviously you want to make sure that there's no damage to these wires, that something easy like a broken wire or a damaged connector. We don't have that problem. We can go on down here to the first test. The first test, we're going to unplug the 2-pin connector I just mentioned that comes from the pump itself. And we're going to make sure that we're sitting somewhere between 0.1 and 1 ohm flat. If it's less than less than 0.1 ohm, then we have an open. So there's a broken connection somewhere inside the windings of the motor or the brushes. If we've got more than 1 ohm, then we've got either corrosion, carbon buildup on the brushes, or something that's increasing resistance. Either way, we can stop here. If we have that, the pump shot, we got to replace the BPMV. If not, we're going to end up going down to this test where we disconnect that C3 EBCM connector that we mentioned first, and we're going to check that one for damage, and then if so, we're going to do a resistance check on that, and then ultimately we're going to do a voltage check on that. So we're going to do all these checks. We're going to see where that leads us. So let's go ahead and start these tests. So the first test is this connector on the back here, and we're going to have to see how we can get the camera down in here so that you guys can see that. All right, guys, for this first test, we're after this connector right here, which is from the BPMV's pump motor into the EBCM. So just got to get this little locking tab to come off blind here, because you guys can see it, but I can't. All right, there it is. All right, and then we're going to grab our ohm meter, bring it down where you guys can see. And we're going to do a test of the resistance between the two terminals to the pump motor. Here and here. Make sure you got the key off for this test. And we want a value between 0.1 and 1 ohm. And we got 0.6, 0.5. It's bouncing around a little bit because my hand keeps moving probably. Just going to hold it and make sure it stabilizes. Yep, 0.4, 0.5. Okay, so that tells us that the pump is not dead. If we had gotten less than 0.1, we would have an open. And if we had gotten more than 1 ohm, we'd either have carbon buildup or corrosion on the brushes of the motor. So that's not what we got. So we're going to move on to this connector C3 on the EBCM and pop it off. Same kind of little tab. You lift up on. Pull it up. And now what we're going to do is measure the resistance from the negative terminal of this connector over to a ground. And the best ground I can think of for this test is just to take it straight from the battery. So we're going to unplug this particular type of connector that we had. And you can see what I've got here is I've got a different meter connector where I've got an alligator clip right on the negative terminal of the battery. And we're just going to plug this guy into our meter. Set him up here. And then we're going to make that measurement and see what we get. All right, so you got a red and a black. You want to do this from the ground line. pop that in there. .5, 2.6. Just twitching a little bit because of my hand. Now that's a hair over the spec we want to pass this test. If we take a look at the manual here, you know, we did this first test where we measured the two terminals in the connector coming from the pump pigtail, and I said you wanted that to be between 0.1 and 1.0. We passed that. We came down here. We disconnected the EBCM connector C3. We made we took a look at it. It's not broken, damaged, cracked, or rusty at the connectors. We go on to this test here, and we measured between terminal B, which is the negative, over to a ground. J392200 is just GM speak for a digital voltmeter. And we want between 0 and 2 ohms, and we're getting just a tad over 2 ohms. So what that implies is a ground problem, right? So if we jump to step 11, it tells us that we need to repair the open, which would be if we had too low or the high resistance in circuit 150. And if we take a look at our schematic here, what circuit 150 is, we're on this connector C3. There's the red is the power. Here's the black that we're measuring from. To G is circuit 150 is going to G101 as one of the ground points, and the other one that 150 connects up to is the signal ground on the EBCM, and that goes over to G104. If you're interested in all these grounds and where they're located for different engines, I'll link something up here in the upper right of the video, a little white circle you can click on. But what we really need to do is go inspect these two ground points, clean them up, and rerun this test and see what we get. Guys, let me come back here because I misspoke, right? I think I said circuit 3. It's circuit 2 and circuit 150. Now, still looking at the schematic, I don't see circuit 2 called out anyway. So, even though I misspoke, we still have to go find it somewhere else. But I did want to add that the ground circuit 150 that they're talking about is G101 and G104. So we're actually going to do both of these, right? So 101 is the one by the battery that I mentioned earlier. But G104, if I grab the flashlight a second, is down here on the frame rail. You can see it way down there. And that's the next guy that we'll check. So let's start with G101. It's one of those kind of days where you got a lot of sun glare. So even though it's bright and sunny, you can't see anything. So I've already started this 10 millimeter. I'm going to go ahead and take him out the rest of the way by hand. I really don't think this was the problem, right? He's nice and shiny. There's really nothing to even burr up on that one. What we'll do is, even though it looks nice and shiny, we'll go ahead and give it a little bit of a cleaning. I'm just going to take a nylon brush on a Dremel tool. I'm not going to use anything metal because the plating's still intact. We'll go ahead and do that to this cable that comes from the battery cable itself. But again, these look really pristine. I try to take good care of these grounds. But just in case, we'll try this out, and then we'll go ahead and brush a little bit of this dirt off of this guy here, even though the plating and everything looks really good. We'll take a brass, little brass pipe brush, sorry, forgot what I wanted to say there, and run it through that hole. So this guy I don't suspect. We'll go ahead and finish up here, and then we'll pick it up down at G104, which does have a little bit of corrosion, so maybe that's a factor. All right, guys, so G101 is fine, so let's take a look at G104 here. So we're going to put a 13 millimeter socket on this bolt that goes to the frame. We're going to work this off. Might have to come up from underneath because these straps are turning out. Let me go up underneath so I can hold those straps. All right, guys, I'm underneath here, and what's working for me is a little 13 millimeter stubby wrench that you can see me using here. And it's a little slower than the ratchet, but it allows me to keep my thumb on my other hand holding on the straps so it doesn't turn. So we're just going to work it off like this, and then we'll take a look. All right, guys, we're underneath here. We can take a look at these straps, and we can see There's really not a lot of corrosion on this first one. Looks in pretty good shape. So we can zoom in just a hair here. Now if we take a look at the bolt does have some corrosion on it. So we'll go ahead and pull him out and wire brush him off. But both the straps look pretty good, but we'll wire them off as well. Whoops. And that's why you wear eye protection, guys. But yeah, the strap's got a little bit of corrosion, but we can still see the plating on both sides. So we'll give the bolt some treatment, and we'll see if that helps any. All right, guys, I'm just going to hold that bolt in some vice grips while we clean him up. We just have corrosion right around the neck of the bolt. I doubt this is contributing to our problem, but it's always a good idea to keep these grounds as clean as you can. I've switched to a regular wire wheel here just because this is some significant corrosion. We're just going to keep going like this until we can clean this up as best we can and reassemble it, and we'll see if it has any bearing on it. Otherwise, we'll continue with the last step in the service manual. All right, guys, after you brush everything off, the last thing is to brush inside. All right, so we're going to use this little brass pipe cleaner just to make sure that where the threads bite, that we don't have any oil or corrosion in there as well. And you know, you have to eyeball this, right? You want to make sure you're seeing bare steel. If it's still corroded in there, you may have to put one of these on the tip of a drill. All right, so now we're going to put it back together. So let me get all the pieces and go back underneath, and we'll show tightening it up. All right, guys, we got G101 put back together down here. You know, I could not for the life of me find a torque value in the service manual for this. So we went with Gutentight and just made it nice and snug. So all I wanted to show you here, though, is since we've brushed off on this where the plating might be missing, what I like to put on these after I do that is something called Cosmoline. This is an older can, so the labeling might look different nowadays, but you just give a spray of this. So we sprayed that on here, and then also, let me grab the flashlight. Also on G104 back here, right down there. If we zoom in, we can see that we sprayed him up as well, just to seal up the work that we did. All right, guys, after we Cosmoline this, I meant to tell you in the previous clip, you want to also check this strap where it goes up and attaches to the back of the cylinder head. If that ground strap is frayed or broken, you need to replace it as part of doing the due diligence on this ground circuit 150 diagnostic that we're doing. You also want to check the mounting bolt and nut that this attaches to on the back of the cylinder head for the Vortec 50, 57, and for the Diesel 65s that have this mounting point, to make sure that that also does not need to be touched up and sanded. If we come back up to the front again, right, and we talked about G101, we want to make sure, of course, if this cable going to G101 down here is broken, frayed, or exposed, you may end up having to replace this whole negative battery cable to fix that problem. Also, make sure you follow the negative battery cable over and check the stud and nut where it attaches to the engine. All that together would be circuit 150 and part of the diagnostic that you'll need to do to hunt down for excessive resistance leading to this diagnostic code. And you see here with this spec here, if we got anywhere between 0 and 2 ohms, this test is good. If we get that, we would have gone and done this voltage test, right? Now, we could go ahead and do that voltage test. In fact, let's do it, right? We'll go ahead and put that test in, and where we're going to end up is, if that passes, it's going to take us right back to the same thing, where it's going to say, hey, you have some kind of a problem with ground, and you're going to need to chase an open or poor connection or corrosion on circuit 150. Now, they got circuit 2 on here as well, but circuit 150 from our schematic up here is what would have been concerning. So if you get this all working, where does it go? Well, if we pass here and we go past here and we pass here, and you end up with step 12 that yes, it still sets as a current trouble code, it would have told you, well, then you need to replace the EBCM. Right? If we had gotten this first test to fail right off the get-go with the pump resistance, it would have jumped us to step 15, and it would have told us to replace the BPMV. But if we get a situation where, all right, this test pass, and this test pass, and now at this point, we can't get the code to set anymore, it would tell us it's intermittent. You're going to have to wait until it's more reproducible. But if we do all this cleaning and checking and we find that it still sets, then the problem is in the EBCM. So either way, we're pulling this electro-hydraulic braking unit. No matter what we do, we're pulling this. If we would have either had to pull it to change the EBCM, or we would have had to pull it to change the BPMV anyway. So what we'll do is, now that we got a better resistance value, we'll go ahead and back the vehicle up and see if we're still getting the code, just to kind of complete the diagnostic check. And that'll let us know where we landed. But either way, we're pulling this. So let's go. All right, guys, we drove the truck and we're still getting the code. So flat out, the EBCM is bad and we're going to have to replace it because our grounds are good, and everything with a code with this top component of the EHBU is going to end up being a replacement of the EBCM. These are not serviceable. When we pull this out, I'll show you more on why. But I did want to show you the one other test I said I would run, even though we didn't need to do it. You know, just to show you that test, I'm going to pop C3 off again down here. Always have trouble getting my finger under that little clip. There he goes. Because you know what you try to do is you want to lift it up just enough to let it go, but you don't want to go crazy with it because it's going on 25, 30 years old and it's going to break. So maybe too gentle with it in some cases. All right, so I'm going to turn it to volts, and we're going to do that voltage test that I showed in the service manual. Now, this test requires us to turn the key on, so I'm going to go inside the truck and turn the key on. Now, when we do this, we're going to generate some new codes. And the reason is that when we turn the key on, we're either powering up the VCM on these gas trucks or the PCM in a diesel truck, and the EBCM is not connected, so the computer is going to flag that with a bunch of codes. So just be ready for that. You'll have to clear those out. All right, so we are going to do positive. Make sure you do polarity correctly here, and negative, red to red, black to black. And we're reading just over 12 volts. And the spec said anything over 10 volts was a good test. So we just ran this additional test just to confirm that all of the tests we could have run passed. So that leaves us with no other conclusion but having to replace this. All right, guys, when it comes to the other problem in this video with the BPMV, there's not a specific diagnosis. I'm going to tell you what the situation is, though. The BPMV was replaced several years ago because the pedal went to the floor. And that's one of the things that these brake pressure modulator valves can cause, because you can get a situation inside where the internal valves are not closing all the way, and so you don't have any back pressure. When you push the pedal down, it just goes straight to the floor. You got to eliminate other problems that can cause that are more common, like a problem with the master cylinder. But if you've eliminated that, it's usually going to be the BPMV if you've eliminated everything else. The pulling to the left or the right is similar with the internal valves. They're not responding fast enough, or they're sticking. And that's going to get you pulling to the left or the right. You got to eliminate the problem being a issue with the front brake line, because you can get that as the more common problem with pulling to the left or the right. The brake line, the soft rubber part, is actually a two-piece design, and so internally the internal piece could collapse a little bit, and that can cause that problem. Or you can just have a seized up caliper that's causing that pull to the left or the right. But if you've eliminated those, then you end up with this problem here. So I put up with that pull that I showed you for a while, because this is an expensive part to replace normally, and it's discontinued, and it's difficult to track down. But when the top piece failed that we just went through diagnosing, I just decided let's go ahead and tackle both at the same time. And I'm quite confident that when we replace this piece along with this piece, and we just basically put a whole new EHCBU on here, our EHBU, electro-hydraulic braking unit, and we put the whole thing together and we replace it, then we're going to knock out both problems. So let's go find out if that's the case. All right, folks, we're going to be under the hood for a while. We don't want to run the battery down, so we're going to come down here, just give this guy a pop so that we don't have the light going. All right, let's get into removing this, folks. So we'll start with our C3 connector that we did all of our testing on. Remember to lift up on the retaining tab right here and pull it off. Then we're going to take this EBCM harness off here. It's got a retaining clip to help keep it from coming loose. You're just going to take this and you're going to pull it out, right? Just pull it out. And then underneath here, you're going to find that there's a squeeze type prong that you use to get this guy off. And this guy's going to be on there really tight if he has never been off. I'll tell you that right now. Try as much as you can to pull by the connector and not the wiring. What I'm going to do is I'm going to go ahead and pull the retaining guy out of this one just to get it out of the way so that I can get my finger up under here and work this guy off. All right, I guess what we'll do here, we'll just abort this and we'll go ahead and try to get them off. After we get this guy more off, we get some better leverage on that connector. Just don't want to do any damage to these wires. One of these wires here, I think it's this guy here, the purple one, is actually the serial data connector line between the EBCM and the pass lock module and the VCM or the PCM if you have diesel. And if you damage that line, the engine won't start. I've seen that on trucks before. This line gets shorted or gets damaged because if the VCM can't communicate with the pass lock module, it goes into theft mode. You'll get the security light and it won't fire up. And that can happen because it has to go through here in order to get to there. So we definitely don't want to put too much stress on this connector. So we'll come and get that later. I'm going to go ahead and take these two 13s off on this side. There are two more on the other side. We're going to lift this guy out, mounted to this mounting bracket intact. Let me show you the one I'm going to be putting in here so you can get an idea of what we're dealing with. So this is a salvage yard EHBU that I've refurbished, right? Cleaned it up, polished it up, checked and made sure that the pump passes its tests, got it in good shape. We've pulled off the bleeder covers and we've cleaned everything off there. We've tested, made sure the switch is okay. Of course, we've got these guys on here so that we don't have any brake fluid dripping around. So this is the guy we're going to put on there, and we're going to have to get him off in order to mount him onto that bracket that's at the bottom. So the way we're going to take this out is this unit on the bracket intact, and we're just going to lift the whole thing out. So we're going to take these two 13s off down here. We're going to release the fittings on the brake lines. They're on these 5 on this side, and then the other two 13s, and we're going to take the whole thing out. And then we should have a better shot at getting this really wedged in here, baked on connector. It's been sitting here for 2.5 decades. It's not really interested in being disturbed. So let's go ahead and get going with that. We're going to leave the other two in to hold things down until we can release all these fittings. So let's reposition the camera, and we'll come over on this side and we'll take those fittings off. I'm going to go over again the tools that you need for this job when you're getting ready to remove this ABS module. So you'll need a 19 millimeter open end wrench, and what we're going to use the 19 millimeter wrench for is to hold these 3 tubes at the top here. When we get ready to remove these top 3 brake line fittings, we're going to use the 19 to prevent these guys from coming untorqued. The other tool you're going to need is very important, is a 9/16 line wrench. When that line wrench has the ability to cover more flats than an open end wrench, and this is what we're going to use to break the torque as well as initially tighten down the brake line fittings. It is good to have a 9/16 open-end wrench. This comes in handy just to do the really quick, repetitive unscrewing and screwing of the fitting once you've got the torque broken. And similarly, a small adjustable wrench is also helpful for speeding through some of those steps. Now, all this really entails is coming in with the line wrench initially. You know, we can show this one in the middle here is probably the best camera view. Right, and we're just going to work this in here. There's plenty of room here. in order to get this loosened up. And there's plenty of room in here to tighten it down when the time comes. Similarly, when we go do this guy on this side, we'll come in from this angle. If we look through the top here with the camera, right, we can see that the line wrench just fits perfectly right onto the fitting like we would want. Now the ones on the bottom, we don't need the 19 because we don't have these tubes up here. And that we'll be able to come in, and again, it's probably easiest for the camera to look straight down. We'll come in here with the line wrench and grab this guy right down there. The ones that are hard are these that are closest to the fender. You can come in between the VCM, if you've got a gasoline engine, and the fuse relay center in order to get this one on the very bottom. Sometimes helps to give this guy a turn. They usually have like a bend to them. We'll get this guy on. Want to get him on evenly, of course. And what you'll be able to do is you'll be able to get him on by going down in between these two. Now it's really awkward, but all you need to do this for is to do the initial braking of the torque. And similarly, when you go to do this one up here on the top, you'll want to have your 19 in position for that one. And again, you're going to kind of come in here from this side here. You might have to work this harness out of the way. We're going to come in here and we're going to break the torque on each of these. It's still real tight, but now we can turn it by hand. All right, we're not going to undo them all. I just want to first get the torque broke on all of them. But we just want to get it loosened up. You can see it's loosened up. All right, so I'm going to go ahead. I'm going to take this one off, or not take it off, but I'm going to loosen this one. And then there's one here on the bottom, and there's one here on the bottom on this side. So there's a total of 5, 3 on top and 2 on the bottom. We're just going to get them up to where we can turn them by hand. And then, so what's going to happen is the brake fluid is going to start coming out. And as soon as we get them loosened like that, we're going to get something under here to catch the brake fluid that's going to end up draining out of the master cylinder. And then we'll go ahead and proceed to take the other two 13mm bolts out. They'll allow us to lift this guy up. All right, guys, we're working this guy off here. Just using a small crescent wrench to get him when he gets where he's too hard to turn by hand. I'm not going to show you all of these, but once you get this brake fitting off, you can slide it back a little bit. You can reach back and very gently pull the pipe out. And then to cut down on the fluid loss, get yourself some kind of a cap. If you don't have a cap, you can get like a Ziploc bag and rubber band it around. That's the approach we're going to use with all 5 of these to cap them off. So we're going to keep on going. As soon as I get the last 5th one off, then we'll come back and continue removing. All right, guys, we got all these capped off. Now we're going to take those other two 13s that we had holding the mounting bracket. Move our flashlight out of the way. Can't see anything, unfortunately. So just trying to feel for where that bolt is. There he is. That guy, and then we've got one more on this side that we probably need the flashlight for. Right there. So You saw him just slide there. Get this bolt out. Put him over here. Now we have a better angle to get these connectors loose. There's that one. So you see, this is the connector you're trying to get to lift up so that you can unplug it. Now this is the guy that was giving us so much trouble on the other side. See, what we're trying to do is get our hand under the pump here. And see, that's the connector's retaining clip right there. And that's the guy we want it to have wedged up a little bit while we pull back. Now we got it off. All right. Now it's still held on by one more thing. So we're just going to kind of rotate it around. We got to get, or two more things rather. We got to get the pressure switch to let go. And then we've got a little harness clip over here. Let's see if we can get some flashlights down here so you guys can see what I'm talking about. And let's see if we can get our flathead in there to release that. And there's the EHCU. And we're holding it like this, you know, to try and keep the brake fluid from coming out. All right, guys, so we got this out. And you can see if we take a look down here, we've got everything nice and neat. Now, you might want to put some tape to make sure you don't get these mixed up. There are several different sizes. We got one that's leaking here. We have to tighten up a little bit. So it's hard to get them mixed up, but if you feel like you want to put some tape to tell which one's top and bottom, I decided to use different kinds of caps instead. So now let's go ahead and take this guy. We got two more things we got to do. If we come over here, we got to take these three 13mm bolts out in order to release the EHCU from the mounting bracket. So if we think about what we were looking at before, if I just set this on this stool, go get our replacement unit. Right, our replacement unit is going to mount to the bracket with those two 13s and bushings on this side and a single 13 and bushing on this side. Now what I'm going to do is I'm going to go ahead and get this mounted to this bracket, but I'm going to take the old one and I'm going to completely disassemble it for you so you can see the different components, right? So the EBCM that's up here, the electronic brake control module, held on by these 4 Torx bolts. And then this piece here with the pump motor is the BPMV, the brake pressure modulator valve. And then this piece right on the front attached to it with these hex head bolts and also holding the pressure switch. This is the brake combination valve, sometimes referred to as a proportioning valve. So those are the 3 pieces. And the reason I'm going to take it apart and talk to you about it is they're not the same. They look the same on different trucks, and the EBCM has no identification marks on it whatsoever. But they're different depending on whether you've got JB5 or JB6 or JB7 or JD7 or JD8. Different kind of brakes take different EBCMs and take different proportioning valves. Also, if you have a G van, there's some differences. A P van, there's some differences. So I'll go over CK trucks, P vans, and G vans, and also go over S and T trucks in just a minute. All right, guys, we're going to take these 13mm bolts that hold the EHCU to the mounting bracket off. There's not a lot of torque on these, or there shouldn't be. It's only supposed to be 9 Newton meters or 7 foot-pounds. If you're missing any of these bolts, you'll be sure you want to take them from the salvage yard because, like everything else, they're discontinued. All right. All right, and that separates our old from our original mounting bracket. Now we got some brake fluid here. We'll clean that off in a minute. And we just want to make sure that our harness clip is okay. That's another thing you can grab from the salvage yard if yours is missing or broken. And we want to make sure our bushings look okay. There's not a lot of rust on these. And I don't see any cracks in the rubber, which is what we're looking for. So we're good to go. Let's bring our new one over here. Pop this guy on like that. Start them by hand because we're going steel into aluminum, right? So we definitely want to start everything by hand. You can line these up. And then what we're going to do is we're going to tighten these back down to 9 Newton meters or 7 foot-pounds, whichever you prefer. There's one click, right? I'm just going to keep going. At this point, once I get this back on, we're ready to reinstall this unit. All right, guys, let's take a look at just real quick some information in the service manual that might be useful to you. Make sure that you take note of where I mentioned in the video about doing a bleed. This is information about doing a 2-person bleed, but the main thing is using the scan tool to do the automated bleed procedure if you've got a gasoline engine. If you have diesel, you're going to have to run what's called a ABS function test. It does the same thing, and they tell you to run that 4 times, and that gets the air out of the brake pressure modulator valve. Something else that's useful to know, and I'll show you a bigger version of this parts explosion because this one's a little hard to see. But on the BPMV, part 2 in the picture, they talk about do not reuse the old mounting screws. So these T25 screws that you see here, they don't want you to reuse them. And when you put new ones on there, the torque is 5 Newton meters or 39 inch-pounds. When we take a look at the BPMV, some important notes on the BPMV, do not reuse the transfer tubes. Always install new transfer tubes. And so transfer tubes in the picture would be these part number 13 here, which are these little aluminum tubes that have 2 O-rings on each end that sit between the combination valve and the BPMV. Those can't be reused. You need new ones there. They also talk about the let's see, do not use a tool to pry the EBCM away from the BPMV. Just use your hands. I'll show you that later in the video. You don't need a tool. You really shouldn't. Maybe at most a rubber mallet. And do not reuse the EBCM mounting bolts. We saw that before. They talk about over here about the 3 Allen bolts that hold the combination valve. They give you that foot-pound. It's a 2-step, so you can reuse them, but you go to 6 foot-pounds or 8 Newton meters first, and then go back around and go to 12 foot-pounds or 16 Newton meters to finish it off. And again, that's the 3 Allen bolts that you see in part number 11 here to hold the combination valve into the BPMV and secure those 2 connecting tubes that you have to replace. They talk about putting a new gasket. Anytime you change the EBCM and the BPMV, you have to have a new gasket, and they tell you do not use RTV or any type of sealant. So you have to use this special little thin gasket that they provide. GM does. And again, do not reuse old mounting bolts with the EBCM. They keep saying that like 3, 4, 5 times, so they're trying to tell you something there. Here they talk about the 3 bolts that hold the BPMV to the bracket and the bushings. Those go to 9 Newton meters or 7 foot-pounds. And if we jump up to the picture, that would be part number 9 here. So there's 2 on this side and 1 on that side. Those get 7 foot-pounds. Finally, they talk about installing the electro-hydraulic control unit. That's everything put back together to the frame. And so they talk about the 3 bolts that hold to the frame. Now that's actually a typo. It should say 4 bolts on this model. And they tell you to take that to 9 foot-pounds. And again, those 4 positions would be these 4 holes here that hold this plate to the actual vehicle that the BPMV and this whole assembly is mounted to. And then the last 2 couple of torque values, they tell you when the whole thing's put together, your brake line fittings get torqued with a crowfoot type of flare nut fitting on your wrench to 22 foot-pounds. And then one other thing that's probably useful to know torque-wise is if you end up replacing or loosening up these adapter tubes they get tightened to 23 foot-pounds. Of course, they have to have a new O-ring. And then again, they repeat that the brake line fittings that screw into them go to 22 foot-pounds. So I hope all these torque values help you out, and I hope some of these pictures help you out. We'll do a teardown next so you can see all this stuff. Guys, I'm going to take this apart and basically give you the parts explosion on it, and then we'll talk about the individual pieces and identification across different model trucks. We're going to start with the combination valve and pressure switch, and then we'll work on separating out the tubes, the EBCM from the brake pressure modulator valve, the BPMV. There you go. Say that 6 times fast. So let me go ahead and set this guy over here, get our first tools, and just tear it apart, and then we'll talk about it. This is going to be a 3/16 hex head. This guy here is going to be a 21 millimeter. This guy here is going to be a 19. There's a small O-ring on here that will work off. The others are exactly the same. Next, we're going to get a T25 to take this off. Let me set some of these parts aside. All right, we take our T25 and we'll remove these 4 bolts. Separate these 2. And then we've got a gasket here. Try to get it off intact. Might not be able to, and all right. So we've got these four bolts here are torque to yield type, so they have to be discarded. We've got our gasket. We've got our combination valve. We've got our pressure switch. We've got our 3 Allen bolts. We took off one of the 3 connecting tubes here. Trying to find our little O-ring that went flying. We didn't take this out, but if we wanted to, just give it a pinch. And that separates out from the bracket. And basically what we've done is we've recreated the parts explosion in the GM parts book. The parts in yellow are the only ones you can still buy. And literally that means out of these 3, only the rear hasn't been discontinued, but I'm pretty sure that's going to get discontinued this summer, if not by the time this video has been published, at least according to my local parts guy. Now, on these, you can tell that they're unique. This one's got 3 notches. This one's got 2. This one's got 1. This is left front, right front, and rear. So right now you can only get the rear. Each one's got an O-ring on it. Normally when you'd buy the BPMV, it would come like this. So it's exposed with these solenoids, and you would have to then acquire a new gasket. If you changed out the EBCM, it would come with the gasket, but you'd have to procure the screws, and like I said, they're torque to yield, so they get discarded after they're torqued down. If you bought the combo valve, it would come with the switch. You'd need the bolts, and would also come with these small connecting tubes. So if we can work these guys out. Take a small plastic lined jaw plier and pull those out. These also have to be discarded and cannot be reused because they typically get sealed when you torque everything down. All right, so that's the parts layout. What you'll see across different trucks, this is the CK trucks and the P vans use this setup. Same common mounting bracket. The G van has a uniquely different mounting bracket, but the rest are very similar parts. And again, everything in yellow is available. Everything that's not yellow is discontinued at the time of this video. And then the S&T truck also has a different mounting bracket, but a lot of the other parts are common. Now, even though the parts are common in cosmetic appearance, they're not common in terms of being exactly the same. These parts vary from truck to truck and van to van. And what I'm going to do is I'm going to show you how they differ. So start with the combination valve. So in the combination valve, you can identify this part because it'll have a letter code on it. You can see this one's an A if we zoom in here. And a CK truck is going to have either an A, a D, an L, or an S, depending on the engine combination. You know, for example, an S is very unique. It's only used on a 3/4 ton Suburban. So unless you have a 3/4 ton Suburban, you'll never see an S-coded combination valve. They're not interchangeable. A P van will use an A or an L. A G van will use an A, D, or E. And an S or T truck, like a Jimmy or an S10 Blazer, will use a B or a J. And I'll show you some pictures of some of these other ones that I have that you can see how these letters vary. You'll have to figure out which of these you need. There's 2 unique ones on the ST, 3 unique ones on the G, 2 on the P vans, and 4 on a CK truck. This one at least you can identify. When it comes to the BPMV, all of them are going to have the same casting number, 127-65501, but they're not all the same. The one for the S&T trucks is unique. Only the S&T trucks have the particular type of solenoids and internal jetting and plumbing that truck has. They're not used on the G, the P, the C, or the K, but they still use the same casting. So you can't use the casting alone to identify a BPMV. A G van also has one part number, but fortunately it's one of the same ones that's used in a CK truck. So S&Ts have a unique one. G vans use one of the types that are from a CK. P vans use 2 of the same types that are from a CK, and of course they're the 2 on the CK. Now the CK trucks, all but a 3500, a C3500 with JF9 brakes uses something unique. All the other ones use the same part number. So you're more likely to get the right BPMV. Again, I'll put some more information in the description. Now let's talk about the EBCM. The EBCM also is varied. There's a lot of different electronics in here, and contrary to what people might tell you, these are not serviceable and cannot be rebuilt. In fact, all these parts I'm showing you were only available from GM. If it was remanufactured, it came from AC Delco, like this one, and it would have been remanufactured by the original vendor, Kelsey-Hayes. They were the only company that ever remanufactured these BPMVs. Anybody that is cracking it open in their garage, you're running the risk of your own life and somebody else's, because this is braking equipment. You don't want to be having this done by amateur night people. These were discontinued back when COVID hit back in 2020. Same with these. So you can't get any of these parts anymore, but you might find them online as NOS, and I'll include the part numbers for that reason. We can see everything in here. The electronics has all been filled with a potting material. Those of you with a 6.5 liter diesel are going to be familiar with this from the pump mounted driver or the fuel solenoid driver. It's all sealed and encased in epoxy. You can't service the electronics inside. Nobody can rebuild these. The only way to get this thing open would be to tear it apart, and then it would not be waterproof anymore, so can't be rebuilt. The S&T trucks have two unique ones. There's no identification on these. They're all going to say the same thing here. These stickers, even if they're legible, are just serial number stickers. They have no part number identification. The G-Vans have three, and they're all unique to a G-Van, and they all look just like this one. The P-Vans also have three, and they're all unique to the P-Vans. And there are 6 different ones for CK trucks, and they're all unique to CK trucks. For example, the one we needed in this truck, we needed an EBCM that was compatible with either JB7 or JD7 brakes. That is not the same as the EBCM for JD6 or JB6 brakes. So all of these computer electronics are geared to operate these valves differently depending on the axle of the truck, the engine on the truck, the transmission on the truck, the weight of the truck. So all very important considerations. So when you go to get one of these from the salvage yard, since you can't buy them new or remanufactured anymore, and tearing it apart like this, I'll show you in the service manual, you can't use any type of RTV for this gasket. It specifically says not to do that, and I guess there's because the risk it could get into the electronics or it could get up on these solenoids and cause damage. You can't reuse these seals, and you can't reuse these bolts because they're torque to yield. So you're kind of hosed on being able to repair these yourself. So you got to take it intact like you see me do in this video. What I would recommend you do, you go to the salvage yard, you find your exact vehicle, your year or newer. So we had a 98 in this video, but we went and looked specifically for a 2000, which is an old body style carryover. So we had a 98 K2500. We went and searched and found a 2000 C3500. It's still the same unit and same part numbers. And we were able to do the repair that we show in this video. I guess the only other thing I could tell you is when you go to the salvage yard, understand that they drain the brake fluid in most places. So you're going to see the master cylinder empty, but make sure it's not full of rainwater, because if it's full of rainwater and it's been sitting without a hood, that water is going to run into this BPMV and there's going to be corrosion inside and the unit's trash. Something else you want to take a look at is you can take a small flathead screwdriver and you can remove these dust caps. In fact, you want to make sure you've got these dust caps to prevent corrosions, particularly up in the salt belt states. And this piece here is made of aluminum, so it's less likely to have that. I'll show you the ones on the combo valve. And you just want to make sure you're not getting water running out of here, right? You should get brake fluid running out of there, if anything. This is on the side of the combo valve, very similar. It has some covers. These are the valves when you do an automatic bleed. You'll see one has a plunger visible, the other does not. That's normal. This is another thing you want to see, that it's not full of corrosion and that those covers have been in place for one of these that you're looking at. So anyway, I hope this teardown helps you out. Again, I'll put the part numbers for the CK trucks. I'm not going to list all these other vehicles because this video is really particular to C and K, but I thought I'd share that information because as you can see in the video, some things are common. If you got a P-Van and you need a mounting bracket, well, you can take it off any CK truck. They all use the same brackets, all 3 of these. All of the G-Vans use the same bracket. All these trucks use the same bushings and the same mounting bolts. They all use the same connecting, these are the connecting tubes, but they all use these same mounting tubes. So if you happen to have those and you can get a hold of one of these O-rings before they're discontinued, then you're set. They all use the same pressure switch. They all use the same hex head bolts to hold the combination valve. If you can find them, they all use the same torque to yield T25s that hold them together. So last thing I'm going to show you is a little bit about mounting this stuff. Sometimes, actually I'll show you on this. This is a better example. Let me see if I got the right one here. I want to get one of these that fits one of these guys here. So sometimes you'll get leaks, weep leaks through here. And the reason you get those when you put this back together, typically it's because somebody has over tightened the fitting. So it's either damaged the flare on the stainless hardline or it's damaged the seat. That's the whole reason these are replaceable. So be sure that when you do this, what I like to do is I like to tighten it down, loosen it, tighten it down, loosen it, and then on the 3rd or 4th time of tightening it down, grab yourself a crowfoot that's designed as a line wrench type or a flare nut type, and you can use that to actually do your torque. This particular one is ratcheting, but anything will do. And then you can do the torquing of this, which is torqued to 22 foot-pounds, and then you won't have those kind of leaks. And if you happen to take this off to reseal it with the new O-ring, it's 23 foot-pounds on these connecting tubes. All right, so let's get back to finishing up our repair. We've brake cleaned off our mount. At this point, we can take off any kind of plugs that you or the salvage yard, or if you bought it on eBay, may have put in here. All you want to do on here is just take a real quick clean rag, get some of this brake fluid out of here, spread some around on the threads, help things go in better, and then just take a quick gander, make sure you don't see any dirt or debris. Sometimes there's some discoloration. You can kind of give that a quick test just to confirm this discoloration. If you give it another rub and it doesn't move or change, then it's discoloration. All right, so now we're going to put this guy back in. You can see we cleaned up where our bolts mount to the inner fender well on this this bracket piece that this bracket mounts to. What we're going to do first is we're going to put this cable that runs here back inside that retainer. This guy right there. Sit him down like this. Yeah, the flashlight decided to take a dive. Now we won't actually clip it until we get a better idea of what the length it has to be is by plugging it in. Let me pause for a second and go dive down there and get our flashlight. All right, flashlight's back in business. So we're going to pull this guy up. Actually, we're going to kind of tilt him where he's going to go. Bring this harness up here and get it into position. Only goes in one way. And it goes in real tight. There it goes. Okay. And then we're going to put this little retaining clip back in. Put this guy back on. Put this retaining clip back in. All right. Put our C3 connector back on. Okay. Bring this guy up. Make sure we're not pinching any of these harnesses. Work our brake lines into position. We want to get our first bolt started to hold this guy. And we get our second bolt started. Once you thread these in about a quarter of the way, then what you can do is go get your ratchet wrench and snug them up, but don't tighten them. We'll go ahead and we'll put the fourth one down the lower corner there in position, and then after we do that, we'll snap the wire retainer for this harness that goes in on this side. And then we're going to, one at a time, uncap our lines and thread them back in. So let me get going with that, and we'll come back when we get ready to tighten them up. And you want to get in here with some brake clean. Make sure you got everything that you spilt cleaned up. And then the next thing we're going to do is we're going to bleed the brakes, and then we're going to use the Tech2 to do a power bleed of the BPMV. So I'm going to be using a motive power bleeder and a one-handed deal, so I can hook these up to each of the wheel cylinders in the back and the calipers in the front. I've already shown this in a previous video, so I will link that up in the upper right here, and you can watch that other video if you want to see how to use a motive power bleeder and how to use the Tech2 to initiate the internal bleed of the BPMV. We're going to do that. We're going to come back. We're going to take it for a test drive and see if we fix this. All right, we've got our system power bled, and make sure when you finish the power bleed procedure, and again, you could watch the other video for that, put your fluid level back where it was to account for the wear of your pads and your shoes. You don't want to overfill it the next time you have to change those out. When you get the guy reinstalled here, just take note of the fittings. They should be at 22 foot-pounds, each one of them. And like I showed in the teardown video, you want to go through a sequence where you work your way up to that. If you accidentally loosened one of these tubes, then those get torqued down to 23 foot-pounds. If you removed it, you're going to have to find a solution for the O-ring like we talked about in the teardown video. At this point, we've bled both calipers and both wheel cylinders in the rear. Now it's time to bleed the BPMV. To do that, we're going to have to hop in and fire up our Tech2 scan tool. So let's do that so we can test this out. All right, folks, once you're all done with the bleeding under the hood, you can go ahead and hook your hood light back up. Don't forget to do that. All right, guys, we're going to go back into the Tech2 now. We've got the key in the ignition on, engine off position. We're going to go back into chassis. We're going to go back into the four-wheel anti-lock. And first thing we're going to do is clear any codes, because the salvage yard EBCM could have some codes left over. So that's the first thing we're going to do. Plus, we have to have all these codes cleared before we're able to run the bleed test. Now we're going to exit out of here, and we're going to go into special functions. And you would have saw this over on the previous test before. Excuse me, the previous video I linked, but I'm going to run this again here. So we're going to go into the automated bleed function. Okay. You want to make sure you've got your parking brake set and that the fluid level is good. Transmission's in park or neutral. And as soon as we press the test, you'll start to hear the ABS pump on the BPMV, hopefully. I don't know if it'll come through on the mic, but you're going to definitely get a lot of pushback on your foot when you push this down. And it's going to push back against you, but just keep lightly pushing down. And hold the brake in position until the test completes. Okay, no codes, bleed complete. So we can hit the exit button and get out of that. All right, so at this point, the last thing we're going to do is we're going to come into system identification, and we're going to make sure to confirm that our platform, date, and software level matches what we had before, so that we know we have the correct EBCM for this particular powertrain combo on this vehicle, like we talked about in the teardown earlier. All right, so at this point, it's the moment of truth, folks. We're going to go ahead and power our Tech2 off, disconnect it from the diagnostic link connector. We're going to fire everything up, and we're going to go give it a test. Okay, no codes currently shown. Go over my shoulder here. We know about halfway down the driveway, we get fast enough to throw the code. Typically, it used to throw it right about here. Don't see anything. That's great. We're going to go ahead and back all the way down to the street. No code. Fantastic. So the EBCM problem is fixed. Now let's go for broke and see if we fix the BPMV problem. So what I'm going to do is I'm going to go down the street just a hair, so that I can get enough runway to do this test, just like we showed the first time. Just going to go right down here and make a U-turn. This is also giving me a chance to test the brake pedal, make sure everything feels right, no sponginess. Everything is working great. Okay, we're going to do a little K-turn here rather than a U-turn. All right, we're going to go back up to the same point that we did in the previous video segment, which is about one and a half or two house lengths down on the street, which is right about here. And then we're going to accelerate up past 20 miles an hour, just like we did last time. We want to watch the wheel here. As soon as we get up to the correct speed, I'm going to hit the brakes. Other than our Tech2 going for a slide, the wheel doesn't pull. So we also fixed the BPMV problem. All right, guys, I hope you found this video useful. It's another epic teardown, detailed part number analysis. It's a good way to learn about how these systems on these old GMT 400 and related family trucks work. If you've got questions, go ahead and leave it below in the comment section. I'll try to help. If you found this video useful, you learned something, or it saved you some money, please tap that like button. And as always, thanks for watching.